This video will focus on area of composed figures. So before we talk about area of composed figures, let's review a couple things about area. Let's start with what area is on a fundamental level. So area is a 2D measurement. So if we think about a one-dimensional measurement, that would be simply like a length. How tall is something, how long is something, how far. If we think about area, what it really means is I'm looking at this, how much space does this square take up? Let's say it's a square. Okay, and if it happens to be 1 inch by 1 inch, we would say this is 1 square inch. Or, for short, 1 inch with a little 2 up above it, 1 inch squared. Now we can apply this thought to any kind of unit. We can talk about feet, meters, centimeters, yards, miles. The same thought would apply. We're talking about how many of these little squares does this object cover. So let's start with parallelograms and review of how to find the area for them. Now normally we think about a rectangle. And typically we would say the area is the length times the width. We're going to change the vocabulary a little bit. We're going to call this the height right here and the base right here. Now we bring that up because this extends beyond rectangles. It goes to parallelograms as well. And the thing about heights and bases is that they are always perpendicular to each other. So if we look at this parallelogram over here, this would be our base, and this would be our height right here. And if I wanted to find the area of either one of these two things, I would take the area would be equal to the height times the base. Okay, before we get to composed figures, let's review area of triangles now. So triangles, the formula, if we follow the same terminology, it'll be 1/2 times the base times the height. Or you could take the base times the height and divide that by 2. Mathematically, it's the same thing. Dividing by 2 is the same thing as multiplying by 1/2. So if we look at this case of a right triangle here, it's pretty easy to determine which one's the base, which one's the height. Again, they are always perpendicular to each other. So I'm looking at this would probably be my base, and this would be the height. If I'm looking at this triangle right here, it's still kind of easy to figure out what the base is. It'd be this guy. And then I look at its height. Now it would be this blue measurement right here, kind of similar to the parallelogram for the in the last example. So that's where we're looking at. That would be the height. And then this last example we have down here, the base might be a little tough to see, but it is this side right here. And then we're looking at the height being this little piece right here. Now let's put this all together. Let's talk about area of a composed figure. So a composed figure is a two-dimensional shape where I can break it up into simpler shapes. For example, this one we have here is a rectangle with a right triangle attached to it. So let's start with the area of the rectangle. If I'm thinking about this, the area would be equal to the base times the height, which in this case, my base, if I'm thinking about it, would be the 7, and the height would be the 5. So the area is going to be 5 times 7, which would be 35 square units. Okay, so that's that area for this piece. All right, now that's not the whole figure. I also want to know about this triangle right here. Now thankfully it's a right triangle, so I have to think about, okay, what's this measurement and what's this measurement right here? The height should be the same as this 5 right here, so that's 5. And then if we think about this, if this whole distance here is 13 and this is 7 of it, then this little piece must just be 6. So the area of this triangle has to equal 1/2 times the base, which in this case is 6 times 5. Now if we do a little simplification here, I believe we should get 3 times 5, which means that the area of this triangle would be 15 square units. Okay, now collectively, we want to add them together. So we're going to take the 35 plus the 15, and the total area is going to equal, looks to be about 50 units squared. That's one example of using our last two formulas to figure out the piece of a more complicated figure. So the challenge lies in, okay, finding these weird little lengths in here. Thinking about what you know to figure out what you need to figure out. Hope this video helps.